ignited the air start motors and jettisoned the ground starts. All 6 solid motors have been jettisoned. Looks like a clean separation.
If you look in the top left corner, you'll start to see the curvature of the Earth.
First stage, when we separate the motors, it's being damped out. As expected, we are now at an altitude of 12 nautical miles. Downrange distance 32 nautical miles at a velocity of 3,200 miles an hour.
Real-time telemetry details are being called out by Boeing's Mark Levine from the telemetry lab, confirming all 6 boosters having separated. Excellent pictures of the launch vehicle as it departs the Earth.
Sequencer. QM on 1. Stage 103. 1, 2, set. We have separated the stages. Go ahead. And there's second stage ignition. Second stage is up and running. Pressure looking good.
Okay, copy that. I'll make sure. Thanks.
Thank you. Okay, we have unlatched and jettisoned the ferry.
5 seconds.
Spin up. We confirm spin up on the video.
It's spinning so that it's stable, and they'll light the next engine.
Third stage has separated from the second stage. Confirmed on video.
Let's see, it's got the flight crew stage and the flight entry system connected together. This is the full spacecraft that you're looking at over here on the right. And the brownish surface that you see is the heat shield that allows the lander to pass through the Martian atmosphere. And the reason this is historic is I think that this is the first full buildup of the flight system. If anybody knows any better, you can tell me. What you see in gold wrapping, that's part of the cruise stage that operates and keeps the systems functioning during the translation of the spacecraft from the Earth. Another back shell, which is turned inverted over here on the flight system. The hole in the top of that conic system is where you put the parachute and the systems that are needed for the initial deceleration of the capsule. This ring with the 2 balls on it, that appears, although I'm not positive it's a flight unit, it looks as if it might well be the flight unit for the other lander. The gray tetrahedron in the middle over there is the second flight unit. The other tetrahedron is inside the brown system. That tetrahedron unfolds so that the rover can drive off. And I think you can see the rover inside. I'm not positive. You'll see a flat shape about midway up the tetrahedron. That's the solar panels of the top of the rover. Just quite similar to what you see from the Pathfinder design, only it's much bigger. This is an interesting thing. It lands with airbags. The thing that actually lands looks very much like the tetrahedron with a skin applied to it. When it lands, it's got airbags all over the place, and you can't be sure what direction it's going to land up. It's not going to necessarily be base down. So the tetrahedron can unfold asymmetrically and right itself. So that with accelerometers you know which way's up, so to speak, and you can unfold and right yourself so that the rover is pointing up rather than down, which is helpful. And then after checkout, the rover actually stands up. It's compressed. I think that description of the Pathfinder rover is a very good one. It stands up and then drives off, and you can see some flight wheels over there on that on the left-hand side. You see the flight wheels attached to their legs. on that bench. Now,
The vehicle,
what?
For the mission that will be started in 88 days, that would resolve.
No, that's that mission is called SIRTIF, the Space Infrared Telescope Facility, which you described. This is the Mars mission.
So when will this start?
Well, it goes in May, right?
Yeah, one is supposed to leave in May and the other one's supposed to leave in June, and it's supposed to make it to Mars in January of 2004.
But it will still get some shield, I mean, just spacecraft or not. You said that this...
No, this is the way it looks after it's let go of by the rocket.
We actually have the movie here.
Oh yeah, let's look at it.
In the atmosphere, this
Little flat thing down there. Now it's on its own.
It's ballistic.
And this is the entry, and that's what the brown stuff is for, is to take up the energy that's dissipated through the heating. And then there goes the parachute. And it's just going through the supersonic phase.
That's animated too?
Yeah, that part's animated.
Yeah, this is it. This is animated. Okay, now the back shell, the white part flew away. The heat shield flew away. There's the tetrahedron, which you see over there. It's falling with the parachute. Now, the next thing that should happen is the airbags should inflate. Boof. There they are. Now, it'll separate from the parachute after rockets fire. Okay, there's the rockets firing. That slows it down to a stop, and then it's let go. And then it bounces. And the Pathfinder one bounced for 1.2 kilometers before it stopped. Now, you might think this is crude, and it is, but it's a relatively safe way to land if everything's okay. Now, these things deflate. You see how the airbags deflate? There's the tetrahedron figuring out which way's up and righting itself. And then there's the rover.
What are the airbags made of, so that they don't...
Cloth and rubber and plastic and, you know, stuff like that.
But otherwise just like an airbag in a car with
well, except they don't deflate.
Yeah, but how do you manage it that they don't...
puncture?
Yeah, on a rock?
Takes a, well, that's one of the tests
get a hole
or design them. In fact, there's an airbag inside of an airbag to keep them from puncturing. And then, so then now the rover stood up and it's on its way.
This landing model is no model for manned flights, is it?
No. No, the airbags are probably not the way we're going to land humans. In fact, they couldn't, the humans can't make it through the environment of entry. I hope I didn't make too many mistakes. Okay.
Sounded good to me.
Okay. The humans couldn't stand the deceleration at the top of the atmosphere. They have to fly through the atmosphere horizontally for a ways to take out the G's.
Area braking.
Yeah, otherwise they would be painted all over the inside of the I mean, really, the G forces would kill anybody inside. Moving over the surface, we won't get any motion pictures because of the data rate requirements, but we will be able to put together stills that make it look like that. Okay, so it's being operated from the ground in these sequences, going to a rock that looks interesting, and then you'll see the arm with the instruments on it sticking out. First it brushes off the surface of the rock so that it gets to clean material. This thing is called the rat, which some bizarre origins. And then you put the instruments, like this microscope, into the little clear, clean place and take a picture of the microscopic image, and then you put the other instruments against that clean spot and determine what the rock's made of. And then you head off into the sunset. Quite literally. Russia and the United States talked about doing a mission together to Mars to show they can work.